Welcome to Pragmatic Testing in iOS. I will be your instructor, Mohammad Azam. Here's a little bit about myself. I'm an iOS developer, coding bootcamp instructor, speaker, author, and also founder of Azam Sharp School. So here are the prerequisites for this course. Knowledge of Swift language is required. This course is not really about Swift language itself. Also, knowledge of Swift UI is recommended. And there are a lot of courses that you can check out which teaches you the Swift UI framework and the Swift language. We'll be using Xcode 16, so any version of Xcode 16 or above would be okay. In this course, we'll be covering many different topics. So here's the outline of the agenda. We'll talk about understanding the test-driven development. We will be writing our unit test, mock, stub, testing Swift UI logic, UI testing, and we will also do service testing, how you can test your third-party services. When we talk about testing, we usually look at the testing pyramid. And this is an example of the testing pyramid. You can see at the very bottom level, which is a much wider area, you are writing your unit test. Next, you have your component testing, integration testing, UI and API testing, and then you have manual exploratory testing. But a lot of tests that you're writing are unit tests because the domain of the application where the business rules are, that is usually complicated and that requires a lot of testing. Okay? And when we talk about testing, we also talk about test-driven development. Test-driven development is basically the idea that before writing a single line of code, you are going to write a failing test. Next, step number 2, you write a test. You fails. Okay? And then you write code, just enough code to make sure that the test passes. Once the test passes, then you can refactor. And during refactoring, you don't really write a test, all right? Because refactoring, the behavior has to be changed, and the test that you have written, it should still succeed because it's checking the behavior. So refactoring should not be changing the behavior of the application. Now, there are a lot of benefits of test-driven development. One of the benefits, the first one, is it helps you understand a complicated domain. And what I mean by complicated domain is, let's say that you are now, going to work for a medical company. So they have a lot of medical terms, right? I mean, maybe we don't know about how the claims are processed. Maybe they're a claim company, insurance company. All of those things have to be learned. So this is your opportunity to learn it by writing tests for the features that you're implementing, because that is how you will learn the domain of insurance company, medical company, oil and gas company, wherever you're working, and tests will help you understand the domain much better. It also gives you confidence for future changes. Whenever you change some part of the code, how are you confident that it's not going to break some other parts of the code? You need that confidence when you are writing your code. You change something, you have to make sure it doesn't break anything elsewhere in the application. And that is what test provides you. It provides you a safety net. So if you fall, there is a safety net of tests that is going to catch you. For test-driven development, I have personally experienced that if you are doing any kind of algorithm-related questions, then it will definitely help you to solve those problems. So that is why test-driven development can be very, very handy, especially in the cases when you're working with a complicated domain. Like maybe you are trying to create some sort of a discount service, all right? And if a person adds 3 items to their cart, then they get 10% discount. But if they add 6 items in the cart, then you get 6% discount. But if they use their own coupon, then the discount will be less, and so on. All right. So it becomes a little bit complicated. And whenever we're talking about these complications, whenever we're talking about the domain, the business rules of the application, they all can benefit from test-driven development. Now, pillars of a good test. Protection against regression. Regression basically means bugs, so a good test will protect you against bugs. Resistance to refactoring. This means that just because you have refactored your application, refactored the code, it should not fail the test. Because remember, your test is not checking the implementation details, it is checking the behavior. So just because you have changed some code, the behavior has not really changed, right? I mean, you have made the code better, but the behavior of the code is still the same. It still returns you what it was returning you previously. So your good test is that kind of a test which will be resistance to refactoring. If you refactored your code, your test is not going to fail because that will be a bad test. That means your test is tied up to the implementation details. Another pillar of a good unit test is fast feedback. So if you're running your unit test, make sure it is running quickly, because if you're running your unit test, it's taking like 30 seconds to run the unit test, one single unit test, and you're just going to give up because you need that fast feedback. And obviously maintainability. So writing your tests that are easily maintainable. Now here's a really nice graph for unit testing, the number of hours spent or work hours spent versus the progress. And one of the things that you will note is when you're not writing unit tests, without the test, your progress is actually, really fast. I mean, you're just smooth sailing at that point. But what happens is initially you are smooth sailing without the test, but as the project actually progresses, then you have some problem because you change something over here, it breaks something over there, you change something over here, and then the other 5 places is breaking, and without the test, you don't really have any good way to catch them. Now, another thing to note in this diagram is the bad tests are also going to pose the same problem as when you are running your application without test. Because bad tests are always going to give you like false positive or false negative, like, oh, I changed something and now the test is passing, but it's not working, or the test is not passing, but it's still working. So, and whenever you're writing the test, you're contributing to the code base because test is basically a piece of code, and code is, a liability. It's not an asset. So we have to be making sure that apart from writing good tests, we're only writing the tests that we need. We have to be very picky about where we can write the test and what to test that is going to give us the return on our investment. And finally, when you're writing good tests, as you can see in this diagram, your progress might be a little bit slow in the beginning, but it will pay dividends as you move to the other part of the future part of your application. Because now with good test, once you make a change and it breaks something else, then you know that you have good test. All right, you will have more confidence to make those changes because if you do something wrong, you have a blanket of tests to protect you. So these are some of the things you need to know about testing, and these are some of the things that we'll be covering in the course also. So let's go ahead and get started.